All right, good morning. Sorry about that. Good morning, everybody, or at least good morning for me. We are going to have our ed puzzle today on energy transformation. So, how does energy go from one form to another? So, without further ado, let's get going. So, when we look at energy transformations, all forms of energy, no matter what it is, cannot be created or destroyed, but it can change forms. And this is actually how we generate all of our different types of energy. So if you think about electricity, you think about heat, you think about sunlight, it all started as a different form of energy. And we can't just create it, but we have to change it a little bit to get into a form that we can use. So where does this energy start? Well, for everything that's located here on Earth or anything that we use here on Earth, the energy had to start in the fusion reactions in the sun. So that stored nuclear energy in the hydrogen atoms in the sun, when they come together in a fusion reaction, they create energy, right, that we get from the sun. This is what we would call solar energy. Now, the very easy, obvious one is that plants use this energy here on Earth to go through photosynthesis. Photosynthesis is the process in which plants make their own food by using the energy from the sun, something we cannot do. Those plants then either become food for us, whether it's eaten by an animal and we eat the animal or we eat the plants directly. Over time, if they decompose correctly, plants and those animals can become fossil fuels, or we can even use biomass. Biomass is recently dead plant material, so if we cut down a tree and we burn the tree, that would be considered biomass. So those become some sort of a fuel. Solar energy in America, solar energy can also evaporate ocean water. Then, when that evaporation occurs, that water can be transported all over the world as clouds. Eventually, that water will be dropped as rain, and that could definitely end up in lakes and rivers. Those lakes and rivers can then be used to power hydroelectric dams. And then also solar energy can also influence the pressure differences that actually create wind. So when we think about windy places, it's due to atmospheric pressure differences. And that is influenced by that solar energy. So all of the energy that we have here on Earth comes from the sun. And there's two forms that we generally think of: potential energy and kinetic energy. Potential energy, when we look at it, is the energy that's stored in an object. Gasoline has chemical potential energy in it before it's burned in a vehicle. Gasoline in a bucket doesn't have any kinetic energy, any energy of movement, but it definitely has stored energy. A rock on top of a hill has potential energy due to its height, right? So potential energy due to gravity. It could fall and it has some energy as it falls. Food, the food you and I eat, has chemical potential energy in it. Our breakfast this morning isn't going to jump up and move, but it allows us to power our cells that make us move inside of our body. And then if you think about your phone batteries don't have energy in the traditional sense of that they're doing work, but as we use those batteries, they can power other devices. But a battery is a stored piece of energy. Kinetic energy then is the energy of a moving object. We've just been learning about power plants. Turbines are a great example of moving objects. Turbines spin, right? And we are able to harness that movement energy and create it into electricity. Electricity itself is the movement of electrons. So electricity is a type of kinetic energy. And then also, you and I move, right? I move based on how much food I ate. If I have energy from the food I ate, I can cause my muscles to contract and relax. That can move my body around. All right, I have mass, right? That takes energy to move. That energy to stop me is also, it takes energy. So kinetic energy is another form. So when we look at it, we look at potential energy, the energy that's stored in something, versus kinetic energy, the energy of something that's already in motion. When we talk about this, we're going to keep it in the mind frame of a typical traditional power plant that uses some sort of fuel source to boil water. The first type would then be chemical to thermal, that first transformation. So chemical energy is stored within the bonds of a molecule. The food we eat has energy stored in the bonds of the molecules. Gasoline in your vehicle has energy stored in the hydrocarbon bonds. All right. And then wood in a fire, that has energy stored between the bonds that make up the cells of the wood. To produce electricity, and this is where we're really focusing, is on that electrical production in a power plant. That fuel source needs to be burned. This could be coal. This could be natural gas. My classes saw the cow power that uses methane gas. It could also be biomass. All of these can be burned, all right, and that burning releases that chemical energy into a thermal energy. Another way to get thermal energy from a stored potential energy is nuclear energy. Nuclear energy is the energy that's stored within the nucleus of an atom. So we're talking protons, neutrons, and electrons now. Radioactive uranium, plutonium, and potassium are often used to power nuclear power plants. What happens is we go through that radioactive decay, that controlled nuclear reaction in a power plant, and that releases energy that we use to heat up water. And that water becomes steam. Now, one thing I guess I didn't really clarify, thermal energy is actually how fast objects are moving. The molecules of an object, how fast they're moving, is really what's going to determine temperature. So high temperatures have lots and lots of movement. So thermal energy is actually a mechanical type of energy, or a kinetic type of energy. Mechanical energy then is that energy of a moving object. So something bigger, like what we're going to look at here with a turbine. So thermal energy to mechanical energy. That thermal energy that's stored in the steam gets those steam molecules moving quickly. That steam puts pressure on the container it's in as those molecules bounce around. And one way we relieve that pressure is by allowing the steam to pass through a turbine. That turbine spins as the steam passes through it. And now we have the mechanical energy of the spinning turbine from the steam. When we get to the mechanical to electrical phase, we have the turbine that's spinning, and that's connected to a generator unit. That generator spins a magnet inside of a wire mechanism. So usually coils of wire inside of a magnet, or one big magnet around a coil of wires. And that, then the spinning of the wires or the magnet changes the way that the magnet pulls on the electrons in the wires. It causes them to move back and forth, back and forth, back and forth. That movement of electrons is alternating current, and this is what we can use as electricity. So when we plug into the wall, we're using the back and forth, back and forth, back and forth movement of those electrons to power devices. So that's about all I have for you today. Please make sure you are up to date on your assignments as we end of the trimester here in trimester 2. As always, talk to your teachers if you need any help. All right, and have a fantastic day.